So here we go on number 45. Is it 45? 44. Sorry, 44. Okay, so paracretosol is a disinfectant used in the manufacture of herbicides. Right here. And I've taken the liberty of writing down the numbers they gave us here. So I've got 0.4039 grams of a sample, and we have 1.1518 grams of carbon dioxide and 0.2694 grams of water. So what we need to know is how many grams of carbon and how many grams of hydrogen and how many grams of oxygen. So let's go ahead and figure that out. And the way you do that, I'm going to show you two ways. I'm going to show you the way I usually think about it, which to me is more straightforward than what the textbook shows you, but I'm going to show you their way as well in case you look at the answer guide in the answer book. And either way works. So we know that you have this many grams of carbon dioxide. You know that there are 12 grams of carbon for every 44 grams of carbon dioxide. So if you do that, you'll have the grams of carbon, because this is the percentage of, essentially this is the percentage of carbon in carbon dioxide. I said 44 and I wrote 14, so 44 grams, sorry. All right, so we get our calculator where we can see it. So we'd have 1.518, and we would multiply by 12, and we divide by 44. So we'd have 0.414 grams of carbon. Okay, let me just do that one more time. I think I wrote a number down. I just double checked the book. I wrote a number down wrong. Yeah, I skipped a 1. So this is 1.1518 grams of carbon. So let's try that again. 1.1518 grams of carbon times 12 divided by 44 equals 0.314 grams of carbon. Glad I caught that. That would have presented problems in a minute. Okay, so that's one way to find the grams of carbon. Another way to do it, a little longer way, but works fine, maybe more logical in some ways. So 1.1518 grams of carbon times 1 mole of carbon is 12.01 grams. Oh, that's carbon dioxide, sorry. 1 mole of carbon for 44 grams. Still early this morning. So that's 1 mole of CO2 for 44 grams of CO2 times 1 mole of carbon for every 1 mole of CO2. And that's because there's one atom in the CO2 formula. Then you multiply by 12 grams of carbon for every 1 mole of carbon, and that will give you 0.3143. So either way works, and this way, the way I did it, I used 12 instead of 12.01. Let's just see if that makes a difference right here. So if I go back to the way I showed you, 1.1518 times 12.01 divided by 44.3144 as opposed to 31.3143, so about the same. Okay, now for water, I'm just going to do it my way, but you could use this pink way up here to do the water, do the hydrogen as well, but I'm just going to do hydrogen by doing 2 over 18, because there's 2 grams of hydrogen for every 18 grams of water. We know that based on formula masses. So 0.2694 times 2 divided by 18, and we get 0.0299. Oh, that's hydrogen, grams of hydrogen. All right, so now if I take my total mass of compound, which is 0.4039, and I subtract 0.314, and I subtract 0.0299, I'm going to get the grams of oxygen. So let's do that. So 0.4039 minus 0.314 minus 0.0299, you get 0.06. Or at least, since I did in 3 sig figs, we'll go 0.060 grams of oxygen. All right, so our three numbers that we want to pay attention to are this number, and that number, and that number. So the first question on 44 asks us to find the percent composition. So let's take a reminder what you said. It said to find a mass percent composition. So to do that, you just divide each one of them by the total. So let's do the percent composition of carbon. So 0.314 grams of carbon divided by 0.4039 grams of compound. So 0.314 divided by 0.4039, and you get 77.7%. I multiplied by 100 in there, and then just times 100 here to get percentages. So 77.7%. Okay, and due to the textbook used a few more sig figs, and they got their answer is 77.83%. So 77.7%, 77.8%, pretty close. That would be fine. All right, now the next question is, what's the empirical formula? So for the empirical formula, you've got 0.314 grams of carbon, you have 0.0299 grams of hydrogen, you have 0.060 grams of oxygen, 1 over 12, 1 over 12.01, 1.1008. Oxygen's right at 16, might be 15.99, let's just double check. Our table says 16.0, so we'll just use 16.0. All right, so 0.314 divided by 12.01, 0.314 divided by 12.01, 0.026, 0.0299 divided by 1.008, 0.0297, 0.060 divided by 16, 0.00375. All right, so divide everything by the smallest one. So I'm just diddling, same thing. So this is going to be 1, 0.0297 divided by 0.00375, 7.92, 0.02614 divided by 0.00375, 6.97. Now in general, again, fourths, thirds, and halves, these are pretty close to whole numbers. I would try that at 7, that at 8, and that at 1. So that would make our empirical formula C7H8O. C7H8O. Yep, that's what the book got to, just double checking. All right, so now it tells us that the molecular weight of this compound is 108. Okay, so 7 times 12 is what? 7 times 12 is 84. 1 times 8 is 8 and 16. So now 84 plus 8 plus 16 equals 108. So what that means is that for this particular compound, the empirical formula and the molecular formula are the same. So the thing exists as molecules in this simplest whole number ratio. So the empirical formula and the molecular formula are the same for that one. And that's it. So those are the problems. Hope that helps. And I'll see you on Tuesday.